Hi guys, this is section 2.1, function and function notations. So just if you look over on the number 1 for things to know, notice it talks about relation and function and the domain and the range. So we'll be talking about what domain and range is, or are I should say, and just kind of keep that in mind that you will be looking for domain and range, not range. Oh gosh, I misspelled. Domain and range for pretty much all the functions that you'll learn from now on. So just make sure you know what it is and how to find it. Okay, here we go. Let's go ahead and move on. All right. So if you remember, right, when we talk about if you read in the book the domain and the range. It basically says that domain is a set of all inputs, and the range is set of all outputs. Okay, so if you look at this relation right here, right? So our input will be the people, and our output will be the birthday. Okay, and the book also mentioned that you can write the relation like an ordered pair. So in this case, I'm going to write it like this: people, comma, birthday. I can't spell today. There you go, much better. All right, so for example here, for Wayne and 310, we can write it like that. So this will be one way to write our relation as an ordered pair. Okay, and we can do the same thing for the rest. So Jeff, and it will be 218. Barry, it's 529. Levon, and Levon is 11/25. Okay, and Ruth is 218 also, and the last one, Celia, is going to be 619. Okay, so this is a way to write out the relation, and for the domain will be the ones that got used. So domain will be Wayne, Jeff, Barry, Levon, and Ruth, and Celia. Okay, so in this case, the domain is actually everybody, because everybody got used. The range will be 310, 1125, 218, 619, and 529. Okay, notice, right, January 1st is not in the range. Okay, January 1st is not in the range because that's not one of the output. Okay, all right, so that's the domain range for a relation. Now let's move on to the next question. Okay, so next question again, right? Similarly, same picture and slightly different. Okay, so let's write this out. My order pairs in this case is I have Wayne at 310, Wayne again at 529. Okay, and I have Jeff 1-1, I have Barry at 11:25. Levon at 2:18. Ruth at 6:19. And Lucilia happened at 2:18. Okay. Alright, so this is our relation right here. Okay, so our relation is pretty good. Our domain, right? Domain in this case again looks like everybody got picked. Okay. Ooh. Okay, it looks like everybody got picked. So Wayne, Jeff, Barry, Levon, Ruth, and Celia. Okay, and the range again, right? We have 3:10, 11:25. January 1st is big this time. 2:18. 6 looks like we have 6:19. And then we have 5:29. Okay, so it looks like everybody got picked as well. It looks like it. Now, so this is a relation again, right, with a domain range, given as such. Now the question here is this a function? Okay, function by definition is this. For every input, there is exactly one output. Okay. For every input, there is exactly one output. That means for every input, you can only have one. You cannot have multiples. Okay. So in this case, I think we have a problem. Notice, if you look at Wayne, alright, this is telling me the same person has two different birthdays. Alright, the same person has two different birthdays. I don't think that happens. Okay, I don't think you can have that. Right, this is violation. This is a clear violation of our function rule. For the same input, you got different outputs. Okay, there's not exactly one, they're different. So therefore, this is a relation, but this is not a function. Okay, this is not a function. Alright. Now, another thing that we want to talk about is this. Usually the input, right, we also call it independent variable. And the output is known as the dependent variable. Okay. So input typically is your x, output is your y, right? So, or we treat it as f of x. Okay. So if you think about it, a lot of times when we write a function or equation, is always f of x equals, say, 2x plus 1, right? So to figure out what f of x is, you have to plug in the number for x. That's why f of x depends on x. So f of x is the dependent variable, and x is the independent variable. Okay, so just make sure we get out some of the definitions out of the way. Okay. All right. So let's go ahead and move on to part C. Part C says, given a relation -2, -4, -3, -5, -1, 3, 4, -5, and 2, -3. Right? The domain and range. And is this a function or nah? Okay. Alright, so in this case, right, let's look at our domains. We have -2, -3, -1, 4, and 2. Okay, I typically like to write my domain from in the ascending order, so smallest first. -3, -2, -1, 2, and 4. Okay. Now range we have 4, -5, 3, -5, and -3. So writing from the smallest, -5. Now -5 here you show out twice, right? You only write down one of them. You don't have to write down both. Just write down one of them. It's just a record says, hey, -5 popped out once. Okay, so -5, -3, 3, and 4. Okay. All right. Now function. Is this a function? Well, I don't see any repeats for the domain. Right? There's no repeats in domain. So we can tell this is a function. Okay, just like that. Look at the domain. Make sure there are no repeaters. Usually, if there's a repeat, and you have the same domain but different range, we got a problem. Okay, but this one I think we're safe. All right, number 3. Assume all variables represent real numbers. Determine whether each equation determines y to be a function of x. Okay, so in this case, right, I will make a table and to create some points. So I'm gonna pick 0 first. Right, usually I pick 0, 1, 2, 3 to see what kind of information I have. So if I pick 0, 1, 2, 3, absolute value of 0 is still 0. Absolute value of 1 is 1. Absolute value of 2 is 2, 3, and so on. Okay. Now let's go back, look at the negatives. What happens when x is -1, -2, -3, and so on? Right? Because this is absolute value. Absolute value of -1 is just 1. Absolute value of -2 is just 2. Absolute value of -3 is just 3. Okay? There is no way for the input to repeat and get a different output. Okay, so this is yes, it's a function. All right. Absolute value of y equal to 5. Now, in this problem, when we're looking for domain of the given functions, right? Oh, it's not, sorry, wrong one. Looking for to see if this is a function. We need to kind of be a little smarter when it comes to pick values. Right? So so in this example, right, because this is not y equals but x equals, so I'm gonna start picking the y value first before looking for x. Okay, so in this case, I'm gonna just pick 6 for y. So if I pick 6 for y, 6 minus 5 is 1. Okay. So now here's the question. Can I pick another number that for y, and I still get 1 out here? Is that possible? Can I pick another value of y when I plug in? Now I still get 1 for 1 for x. Well, try it out. Right? So if x equal to 1, so the question here is y minus 5 equal to 1, right? Now remember on the last section when we did the absolute values, this means what? This means either y minus 5 equal to 1 or y minus 5 equals negative 1. Right? So in this case, if you solve for y, you get y equals 6, which we have, or y equal negative 1 plus 5, which is 4. And in this case, we got a problem. We have 1 6 and 1 4. So this is not a function. Right? Because we have the same input, but different output. So this is not a function. Okay? Alright. Problem C, you got x plus 2 equal y squared minus 5. So in this case, right, let's see what we have. If we solve for x, we get x plus 2 equal y squared minus 5. So minus 2 on both sides. X equal y squared minus 7. Okay. So I'm gonna make a table again. All right. I'm gonna pick some y value. I'm gonna pick y equal, let's say, I don't know, something a little easier. How about let's do 3. Okay. So if I pick 3, right, I get x equal 3 squared minus 7, which is 9 minus 7, which is 2. Okay. Now the next part is the recognized part, right? You gotta be pretty familiar with this, with the function. Is there another number when I put it in y that I will get 2 back? So let's solve for y and see what happens. So I plug in 2 for x and solve for y. So if I add 7 to both sides, I get 9 equal y squared. Okay. And when I solve, this is a square root property, so if I square root both sides, I get plus minus square root of 9, which is y. So this means y equal plus minus 3. So when x equal to 2, I can have 3 or negative 3. And in this case, we got a problem. This is not a function. Okay. Yeah, so these are just things that we have to do. If I see a y is being squared, right, or x is by itself, a lot of times I want to make sure I double check, because those are the type that we're not familiar with yet. Okay, part D, take a wild guess. Okay, take a wild guess. This is probably not a function, and we can figure this out by picking the correct y values. In this case, I'm going to pick y equal to 5 and y equal to 3. Okay, two separate problems. Now, what happens when y equals to 5? You get x minus 1 quantity squared plus 5 minus 4 squared equals 5. This is x minus 1 quantity squared plus 1 equals 5. So x minus 1 squared equals 4. Okay. Well, so check this out, right? So if you try to solve it, you get x minus 1 equal plus minus 2. So this is x minus 1 equal to 2, or x minus 1 equal negative 2. So x equal to 3, or x equal to negative 1. Alright, now so we get either 3, 5, or we get negative 1, 5. Doesn't sound too bad. Okay, but now let's test 3. So if you use 3, we get x minus 1 squared plus 3 minus 4 quantity squared equal to 5. So this means x minus 1 quantity squared plus negative 1 squared equal to 5. This is negative 1 squared is the same as the positive 1. So this is now x minus 1 squared plus 1 equal to 5. So x minus 1 quantity squared equal to 4. Exactly same thing we have here. So that means we should get the exact same work as this. So we end up getting when y equal to 3, when y equal to 3, we get x equal to 3 or x equal to negative 1. And here is where our problem comes. Same input, but different output. That clearly fails our definition for functions. Okay, you should fail 2 spots here also. Okay. All right. Let's move on to the next set of questions. Okay, domain of the given functions. First one, you have a function that is a linear function. Right? I think we've done enough linear function that you probably know that what this one should look like. This is one that looks like this. Okay, and notice, right, there in the line, if you look at it, there's no restrictions, right? You can plug in any number you want. Positive, negative, or 0. Right, you can plug any positive number, any negative number, or 0. So in this case, the domain is going to be all real numbers. Okay, or negative infinity to positive infinity. Okay, you're gonna realize that a lot of times what I always look for is, I separate all the numbers into positive, negative, or 0. And then that's where I start looking at. Can I plug in any positive numbers? Can I plug in any negatives? Can I plug in 0? That's what I look for. Okay? All right. Part B, you have a function that is the square root of 3x minus 4, right? So in this case, what do you know about square roots? You remember, anything under the square root has to be positive or 0. Okay? The number underneath the square root cannot be negative. So that means 3x minus 4. It has to be greater than or equal to 0. Okay? We're not talking about imaginary numbers. We're talking about just real numbers. So this has to happen. So we can set this on using an inequality. Then we just gotta solve it. 3x is greater than or equal to 4. X is greater than or equal to 4 over 3. And this right here is our domain. Domain will be from bracket 4/3 to positive infinity. Okay, depending on what kind of a function they give you, you have to know. You gotta know the property for it, and these are just some of the things that I always test. Alright, the third one, you have a function that is the negative of cube root of 4x minus 6. Okay, so I'm going to ask myself the same question just like the square roots. Can I take a cube root of a negative number? Can I take a cube root of 0? Can I take a cube root of positive number? Right? So if you can do all that, then I think we're okay. Now, so can we take a cube root of a negative number? Answer is yes. For example, cube root of negative 8, that is negative 2, because negative 2 cubed is negative 8. Okay. Can I take a cube root of 0? Answer is also yes. Because cube root of 0 just means it's 0, because 0 cubed is 0. Now, can you take a cube root of positive? That's definitely yes, because cube root of 8 is 2. Because 2 cubed equal to 8. Okay? So, all three possible choices are all yes, so which means the domain is going to be all real numbers. Whoops, this should be a parentheses. Alright. Okay, the part D, you have a fraction. So what kind of restriction do we have for a fraction, if you remember? Right? A restriction for a fraction is what? Denominator cannot equal to 0. Right? So that means whatever number we plug into x makes the denominator 0, that's something that we cannot have. So what we're going to do is we're going to set it to equal to 0 on purpose, and then we're going to exclude it. Alright? So 2x minus 4 equals to 0. This means 2x equal to 4. And this means x equal to 2. So this number is going to be excluded. Alright? So that means our domain will be from negative infinity to 2 parentheses union or 2 to positive infinity. This is what it looks like on a number line. The line keeps going, but 2 is not part of it. Okay? Alright, part E, you have the function of 2x plus 1 over x squared minus 8x plus 12. This is going to be similar to the previous problem. Let's factor the bottom and see whether we can solve it. Okay. So the denominator equals 0 on purpose. This is going to be x and x. And this, I believe, is going to be a minus 6 minus 2. And you can tell from here that x cannot equal to 6. And x cannot equal to 2. Okay. So if we write this on the number line would be like this. Here is 2, here is 6. They're open circles because they're not included. And that's what our line will look like. So our domain is going to be from negative infinity to positive 2, union between 2 and 6, union 6 to positive infinity. Okay, so this will be our domain right here. Alright, rational functions gets a little messy, but it's definitely doable. Okay. All right. Evaluate. Just remember, evaluate means simplify, or in this case, plug and chug. Okay, I'm surprised that some of the students have not heard the phrase plug and chug. Plug and chug simply means you just plug it in. Alright, so for example, if you look at f of x equal 5x minus 8, f of 0 just means wherever you see a 0, wherever you see an x, you put 0 in there. And then you just evaluate. So f of 0 is going to be 5 times 0 minus 8, which will be negative 8. Okay. F of negative 1, same idea. Wherever I see an x, I plug in a negative 1. So this is 5 times negative 1 minus 8. So negative 5 minus 8, which is negative 13. F of 2x. Right, same idea. Okay, we're going to plug in wherever I see an x. Now I'm going to replace with a 2x. So this is 5 times 2x is 10x minus 8. Okay. The last part, f of x plus h. Again, just plug it in. So wherever I see an x, I replace it with x plus h. And then I just simplify. 5x plus 5h minus 8. Okay. Alright. Now the rest is going to be the same idea. It's just that depending on what kind of function you have, it might get a little messy. So now the second function we're going to be dealing with is f of x equal 2x squared plus x. Alright, so let's go ahead and start plugging out values. F of 0 is just going to be 2 times 0 squared plus 0, which is 0. F of 1, negative 1, I'm sorry. It's going to be 2 times negative 1 squared plus negative 1, which is 2 times negative 1 squared is 1. 1 times 2 is 2. So 2 plus a negative 1, which is 1. Okay. f of 2x, that is going to be 2 times 2x quantity squared plus 2x. Quantity 2x squared is 4x squared. So 2 times 4x squared will give you 8x squared plus 2x. Okay. F of x plus h. This one is going to be a little interesting because we're actually squaring the x. So this will be 2 times x plus h quantity squared plus x plus h, right? Just plug it in and we'll worry about what happens afterwards. Now, this one, the x plus h quantity squared, you have to FOIL. So this becomes 2 times x squared plus 2xh plus h squared, if you FOIL it, plus quantity x plus h. Okay. To finish this part, all we gotta do is, we gotta distribute the 2. So you get 2x squared plus 4xh plus 2h squared plus x plus h. And none of them are like terms, so that's our answer. This one's pretty long. It gets a little bit long. Okay. Alright. So we're going to go ahead and keep going. Part C, you have 4, f of x is 4 over x minus 4. So f of 0 is just going to be 4 over 0 minus 4, which is negative 1. F of negative 1 is going to be 4 over negative 1 minus 4, which is 4 over negative 5. F of 2x is going to be 4 over 2x minus 4. Now this one we can probably reduce a little bit. This is 4 over 2 parentheses x minus 2. And we can cancel out the 2 and the 4. So you get 2 over x minus 2. That's your final answer. Alright, f of x plus h. So you get 4 over x plus h minus 4. Nothing exciting here. We're done. Okay, there's nothing really we can do with that. Okay. Alright, part D, f of x is square root of negative x plus 9. So plugging all the numbers, f of 0 is negative 0 plus 9, which is just square root of 9, which is 3. F of negative 1 is negative of negative 1 plus 9, and that's going to be square root of 1 plus 9, which is square root of 10. F of 2x, pretty straightforward. Negative 2x plus 9, that's just negative 2x plus 9. None different. Last part, f of x plus h is square root of negative x plus h plus 9. Not much you can do besides distribute the negative. Negative x minus h plus 9. Okay. Alright. So that's it for the evaluation. Plug and chug. So it should be pretty straightforward. Let's move on to the difference quotient. Okay, difference quotient. First, let's talk about difference quotient, what that actually means. The difference quotient, the formula given to us is f of x plus h minus f of x over h. Okay, that's the formula. But what I want you to think about this is treat difference quotient like a slope. Okay. And by the way, if you are planning to take calculus, you're going to see difference quotient maybe week 1 or week 2 of the course. All right. Now, this is the reason why difference quotient is important. There might be times where you are going to see a function that is not linear. So, for example, you got some function like this. Okay. I'm going to call this function f, and so this right here is x, and this is f of x. Right? And now, for example, if I move the point to the right a little bit, say over here, so that means the x value have increased, for example, by units of h. Okay, so that means the new point here is going to be x plus h. Right? Basically, whatever x is, we add h to it. It's our new location. All right. And remember the function notation, right? Function is you plug in the x. So the corresponding y value for the new point is going to be f of x plus h. All right. So now we have 2 points. We have the first point, x, f of x. We got a second point, x plus h, comma, f of x plus h. Right? I probably don't need to print these here. So this is we'll erase it and leave it out. Okay, so now if you use the slope formula, right? y2 minus y1 over x2 minus x1. If I call this y2, y1, x2, x1, what we're going to have is f of x plus h minus f of x over x plus h minus x. And you can see from here, I can't do a whole lot with the numerator, but the denominator I can simplify. The x will cancel out, and you're left with h. Okay, so this is why the difference quotient is actually a slope. Okay, it's actually a slope on the line that is not linear. Okay, and the other thing that you'll actually learn is the average rate of change. Right, average rate of change. Is actually the same idea, except this one is more much more theory involved than the actual calculation. Alright, so this is a reason for the difference quotient. So let's do this problem. F of x is negative 5x plus 1. Alright, so here we go. F of x plus h, I need to figure that out. That is negative 5 times x plus h plus 1. Simplify is negative 5x minus 5h plus 1. Okay, so now if we take this information and plug into our difference quotient, what we have is f of x plus h, which is this whole thing here, minus f of x, which is this whole thing here. Now, suggest you put parentheses around negative 5x plus 1. It is much better to put a parentheses there to surround the f of x so you don't get burned on the sign. Okay? On the bottom, let's just go ahead and put h. Now I would like you to simplify the top. if you simplify the top, you're going to realize this is going to be negative 5. I'm going to write below it. Negative 5x minus 5h plus 1. Negative is positive, so plus 5x. Negative and the positive is negative, and the minus 1. All over h. Simplify the numerator, you're going to see that negative 5x and the 5x cross out. Plus 1 minus 1 cross out. So you're left with negative 5h over h. Now we can reduce. We get negative 5 as our answer. Okay. So the slope of negative 5x plus 1 in this case is a constant negative 5. It is always negative 5. Okay. Now you're not always going to get a difference quotient that is a constant, right? In the next example, you're going to see that the difference quotient is not going to be a constant. It actually changes. Okay. So here you go. F of x is 2x squared minus 3. I need the f of x plus h. So let's figure out what that is first. F of x plus h is going to be 2 times x plus h quantity squared minus 3. Okay. This part we have to FOIL. So this after FOIL, you get 2 times x squared plus 2xh plus h squared minus 3. The FOIL is a side work, but there's a formula for FOIL. So if you remember the formula to FOIL, perfect square trinomials, you'll go pretty fast. This is going to be distribute 2x squared plus 4xh plus 2h squared. And then we still have a minus 3 at the end. Okay. Once we got the f of x plus h, let's plug into our formula for difference quotient. You get 2x squared plus 4xh plus 2h squared minus 3 minus the f of x, which we will put inside the parentheses, 2x squared minus 3. And all over h. Okay. Alright. So let's go ahead and clean up the numerator, right? We're going to simplify the numerator. So if you take away the parentheses, you get 2x squared plus 4xh plus 2h squared minus 3 minus 2x squared plus 3 over h. Good things happen. 2x cancels out. Minus 2x. Minus 3 cancel out with a positive 3. With that, you're left with 4xh plus 2h squared over h. Our goal here is to cancel out the h in the bottom, so I'm going to find the GCF, the greatest common factor of the top. If you look at it, the greatest common factor of the top, well actually I don't need a GCF. I just need a factor of h. So I'm going to factor h out. GCF in this case doesn't really do us anything. Factoring h out, I get h times 4x plus 2h over h. H cancels. You're left with 4x plus 2h. And this right here is the difference quotient. Okay? And notice, right, this one is different than the previous question. Previous question is just a solid number, negative 5. And this one, it's got h, it's got x. It's still starting to look a little bit weird. The last difference quotient, 2 over x minus 1. Okay? So this one's going to be a little tricky because this is a rational function. Rational function is always messy. But we will make it work. Alright, here we go. I still need my x plus h. So this is 2 over x plus h minus 1. Plug into my difference quotient. This is 2 over x plus h minus 1 minus 2 over x minus 1 over h. Okay. In this case, I have a fraction inside a fraction, so I need to simplify it, right? So this is where I'm going to multiply the top and bottom by the common denominator. And our common denominator in this case is you just simply multiply the denominators together. So I'm going to multiply the top and bottom by x plus h minus 1 times x minus 1. And do that on top and bottom. Oops. A little too excited. Okay. Now on the top, if you distribute, you'll notice that things will cancel out pretty nicely. First fraction will cancel out the x plus h minus 1, so you're left with 2 times x minus 1. Minus 2 times second fraction, x minus 1 gets cancelled out, you're left with 2 times x plus h minus 1. All over x plus h minus 1, x minus 1. Okay. Cleaning out the numerator, you get 2x minus 2 minus 2x minus 2h plus 2 over x plus h minus 1 over x minus 1. Reduce the numerator. This turned out pretty nicely. 2x cancels. Minus 2 plus 2 cancels. You're left with a negative 2h over x plus h minus 1 times x minus 1. Good things happen. H's gets canceled out. So the difference quotient is going to be a negative 2 over x plus h x plus h minus 1 times x minus 1. This is the DQ. Okay. All right. Hopefully this is good. We'll get you started. If you have any questions, again, post on the forum, on Blackboard. Shoot me an email, whsieh@grcc.edu or 616-234-4729. Okay, I'll talk to you guys later. All right.